Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, we're finally tackling the last problem on the 2021 Fall AMC 10B test, namely number 25. So this problem states a rectangle with side lengths 1 and 3, a square with side length 1, and a rectangle R that are inscribed inside a larger square as shown. You have this, this, and this. The sum of all possible values. So that's a bit quirky. Why does it ask for all possible values? So if we get just simply one value, we should be at least a little bit skeptical of our result. But we shouldn't take that as, kind of leading us to how we're tackling this problem. We need to take a look at the diagram first and get any information we can out of it first before going back and checking that we do have all possible values. So let's continue. For the area of R can be written as m over n, where m and n are relatively prime positive integers, and it asks for m plus n. So that's a pretty standard format. So basically we want to find the area of R by any chance. So in any of these questions where, the diagram seems a little bit slanted or it doesn't really help us for us to have, not parallel sides, we can have a lot more traits or characteristics we can dig out of if those are actually squares or rectangles with a lot of 90 degrees or perpendicular or parallel lines. So in trying to do so, we can construct as many right triangles as possible to split this question or split this diagram into as many, normal, quote-unquote, normal as in perpendicular shapes as possible. So now we have divided these into several right triangles and squares and rectangles originally. So we can see that this angle, if I say this angle is alpha, because this is 90 degrees, this is 90 minus alpha, this is 90 degrees, so this is alpha, which means that these two, I'll use check marks, these two are similar. And additionally, these two also have 1, so they're actually congruent, but just using the claim of similar would be enough over here. And over here, by the same argument, kind of the same argument, if you take a look at this triangle over here, this triangle has 1 and 1 over here, which means that this is a isosceles triangle. If we construct it so that it is perpendicular to the base from the vertex, then these two triangles are congruent. And using the angle argument, we could say that these two are also, all of the check-marked ones are similar, along with this and that. And if we have other ones, if we have this one, look at the angle of that is equal to the angle of that, which means that this one is similar to that. And this one is similar to that one as well. We can disregard the one in the middle. It's really like all three sides are slanted. Even if we try to divide it, it wouldn't be of much use. And we can just ignore it for now. Let's just focus on the outskirts of things. And also with this check mark, this triangle is also similar with all of these check marks. So if we let this side to be A and this side to be B, then, this is B, this is A, because all of these triangles are congruent. This is B, this is A, this is B. And over here, notice that these two are not congruent. Even look at these, you can tell these are not congruent. They have a similarity factor of 1 to 3, which means that this side is 3A and this side is going to be 3B. And this has a similarity factor of 3 to 1, or you can say that these two are congruent, which gives this as A and this as B. Now we're given that the large square is a square, so we can set side length equals side length. So A plus B plus B plus 3A is equal to 3B plus A. There are two B's here, canceling out, we get a B. And if we cancel out this A and this A over here, we get B is equal to 3A. Now we can replace some of them. Well, just for convenience, we just replace one of them. If this is 3A, then we can use Pythagorean theorem on this right triangle over here. We would get A squared plus 3A squared, or the quantity 3A squared is equal to 1. So 10A squared is equal to 1. So A squared is equal to 1 over square root of 10. However, that number is kind of tricky to tackle with, so we can scale everything in the figure by square root of 10. Scaled by square root of 10, so that, well, just remember that at the end we scale back. Now, it is much easier to calculate. So, oops, my bad. This is just A, not A squared. Well, if we scale it, then after scaling it, A prime is just 1, B prime is just 3. So, can replace that with a 1, replace that with a 3, replace that with a 3. Now we have used all of the check-marked triangles to find our side length, which is technically square root of 10 but we scaled it by another square root of 10, so the side length is going to be 10. If you just add up A plus B plus B plus 3A, so that's 1 plus 3 plus 3 plus 3, that is going to be 10. Now, let's take a look at these circled similar triangles. If we, this is 3, so if we let the the ratio of these two sides be R, then this is 3R. Because these are similar, so we can find this side because the side length is 10. So that is going to be 6 minus 3R. And over here, this is going to be multiplied by another R. And over here, you can see that these two are actually congruent triangles. So this is 3, this is 3R. And that over here, we know that this is similar to that one. And we know that A to B is 1 to 3. So this should be 3R. And this side should be just a single R. Now we can set the right-hand side equal to the side length. Remember, the side length is now 10, so R times 6 minus 3R plus 3 plus R plus 3 is equal to 10. And move the 10 to the left-hand side. We get negative 3R squared plus 6R plus R is equal to, minus 4 is equal to 0. Multiplying by negative 1, we get 3R squared minus 7R plus 4 is equal to 0. We can easily factor this to R minus 1 times 3R minus 4 is equal to 0. And now you can see that where the all possible values come into play, because both of these R values work. They just provide different values, but both of these, when plugged in, doesn't have any errors with it. So if R is equal to 1, then let me pick a different color. Let's say green. If R is equal to 1, then this side is 3. This side is 3 times 1, which is 3. This side is 6 minus 3, which is 3. And this side is 1 times 3, which is 3. And this side is 3 square root of 2. This side is 3 square root of 2, which means that the area is 3 square root of 2 squared, which is equal to 9 times 2, which is equal to 18. But remember, that is after scaling it, which means that if we, before scaling it, it's actually 18 divided by square root of 10 squared, which is 9 over 5. Now let's take a look at the other case. Let me pick orange. So if I have 3 at this side, then 3 times what we have is r is equal to 4 over 3. This side will be 4. This side will be 2 because that would be 6 minus 4, which is equal to 2. And this side will be 4 over 3 times 2, which gives us 8 over 3. Over here, this is just a simple 3, 4, 5 triangle. So this side has a 5. And remember, these two triangles are similar. So this triangle must be a 3, 4, 5 triangle as well. And if we write it as, well, it might be easier to recognize it is a 3, 4, 5 triangle if we write 2 as 6 over 3. If we write 8 over 3 as 8 over 3, you can see that the diagonal is 10, or hypotenuse is 10 over 3, which means that we have A2 prime is 5 times 10 over 3, which is 50 over 3. But if we scale it back, we have 50 over 3 square root 10 squared. Because we're considering area, so the scale value has to be squared to divide it by. For example, if I have, let's say, 2 similar triangles, let's say 1, 3, square root 10, but let's just make a square. If I have side length 1, 1, then the area is 1. If I scale it up to 2, 2, then the area is equal to 2 squared, which is 4. So the area is actually multiplied by 2 squared. So same thing with here. We actually do not divide by square root of 10. Instead, we divide by just 10. So we get 5 over 3. Now we have to add up the possible values, which is we get 9 over 5 plus 5 over 3. Find the common denominator. We get 52 over 15. And that 52 over 15, if we add up 52 plus 15, we get 67, which is our answer choice E. And that will be our answer for this problem. Thank you for watching this episode of Investigation. And we are finally done with this set of AMC problems. And we'll move on back actually to finish our Amy series I left off just a long time ago. If you still recall that, good job on following this channel. But if not, you can take a look at my playlists and take a look at those video solutions as well. As always, I hope you have a fantastic day and peace out until next time.